In this video, we're going to use conversion between exponential and logarithms to help us solve a few types of equations. Our previous video showed how a logarithm can undo an exponential to help us be able to solve that sort of equation and use our calculator. Here we're going to look at different types of logarithm equations to be able to solve. So, first of all, we know that the bases have to be the same, and we know that the output of a logarithm is the exponent of that base. So make sure you take a good close look at this statement, because these are equivalent statements. They're not undoing each other, they're just saying the same thing. Right? So y equals 3 to the x is the same thing as x, that exponent, being equal to log base 3 of y. So in these three equations, you have log base 5 of 125, that's going to equal 3. Right? Because 5 to the third power is 125. So if you want to rewrite that, you would just say 5 to the third power is equal to 125, which makes sense now when you write, maybe makes more sense now when you look at it this way, 5 to the third. For the second one, you have 2 to the negative fourth, because this is the base, that stays as the base here. The output of the logarithm is the exponent of that base, right? So the output of the logarithm here, where there was x before, is in the exponent, and that is going to equal 1 over 16. And remember, 2 to the negative fourth, right? So that's got a negative exponent, so that could be converted to say, well, that's really like 1 over 2 to the fourth by making that negative exponent into a positive, and then 2 to the fourth power is 16. So that's why that works without needing your calculator to be able to do it. And same here in this last problem, if you have 64 in the base, the exponent is going to be 1/2. Because again, the 1/2 was the output of your logarithm, and the output of logarithm is the exponent, so you have 64 to the 1/2. That is supposed to equal 8. So without a calculator, how would you understand that that works? Here we have to remember that a 1/2 as an exponent is the same thing as a square root. So that's really saying the square root of 64, because that's what an exponent of 1/2 is. There's a 2 sitting right here. There's a power of 1 right there. So we talked about power over root in our previous units. And so the square root of 64 is 8. Here we have a few examples where you're trying to solve for x, where x is located in different places in each of these logarithms. Most of the time when we use a logarithm, after this is going to be based on something that looks like this first example. Much like how we started this section where we had a 3 in the base and you're trying to set it equal to 80, here we have 2.8 to the x is equal to 104. So we're trying to find out what power of 2.8 is going to get you 104. That's unlikely something that you know off the top of your head. And this is the very reason why we have logs to be able to solve, because if x is in the exponent, you're going to use them. So what we're going to do is we're going to take that base of 2.8 and use it as an inverse of that exponential equation. So we're going to do log base 2.8 of that 2.8 to the x, and you're going to do that on both sides. Right, so you're going to set that equal to log base 2.8 of the right side, which was 104. And the whole point of doing a logarithm of an exponential is that they have the same base, so that this log base 2.8 and that 2.8 cancel, and you're left with just x equals your log base 2.8 of 104. Now, being able to solve this is something, again, it's like, well, that's my solution, but it doesn't really give me any information about the numeric value. And so that's where we're going to convert it using our change of base formula, where you would do log of 104, see that now, that's the base of 10, and on bottom, I'm going to do log base 10 of 2.8. Right, so both of those are things that you can calculate on your calculator. Right, so do log of 104 divided by log of 2.8. And if you do that correctly, you should get 4.5108 as your answer. So 2.8 to the 4.5108 as an exponent is equal to 104. And yeah, I did round that to 4 decimal places. The second example is where we have our x in the base. Now that's pretty rare, but when it does occur, we want to convert this into the other form. So we're going to convert into exponential form. So when we're doing our converting, we know that you have a base of x, You also know that the output of your logarithm is the exponent of that base. So we're going to put a 3 up here. So x to the third is supposed to be equal to 14. And so remember, the base stays as the base. The output of your logarithm is the exponent, and it's going to be equal to that 14. Now that you have it written this way, you have x to the third is equal to 14. And so this is one where we can just do the cubed root of both sides. And so you have to do the cubed root of 14 on your calculator. And when you do so, you get 2.4101. Finally, we have an example where the variable, the unknown, is in the logarithm. So we know the base, we know what you're supposed to get out, and so we're going to also convert this into an exponential. So in doing that, we know what our base is. Our base has to be 2. We also know what the output of our logarithm is. It's got to be 12 because that's what the output is here. The output of logarithm is the exponent of that base, and that's supposed to equal x. So base, output of the logarithm is equal to whatever's inside. So here we just have 2 to the 12th, which you can also do on your calculator, which means that x is equal to 4,096. So this video hopefully helps for solving for x when you have x in your different places. Again, if x is in the exponent, you use your logarithms as inverses to be able to solve. Then you're going to need to use your change of base formula and your calculator to evaluate. If x is in the base, you're going to convert to exponential, and then you just have this exponent that you have to undo, so they do the cubed root in this example. And finally, if x is in the logarithm, we're going to convert to exponential, or you use your exponential as an inverse to be able to undo it.